Hi everyone, welcome to Trigonometry. Today we explore lesson 10, Trigonometric Identities, part 2. Number 1, Advanced Identities. Sum and difference identities. Psi of s plus t is psi s cosine t plus cosine s psi t. Psi s minus t is psi s cosine t minus cosine s psi t. Cosine s plus t is cosine s cosine t minus sine s sine t, and cosine s minus t is cosine s cosine t plus sine s sine t. We only need to prove the sum identities because different is the sum. You just have to take s plus minus t and then use the sum formula. So to prove the sum identities, the first thing is make sure that we are able to get a right triangle inside a square so that the hypotenuse of the right triangle is exactly 1. Now let's get some angle in there. That is the angle S, and this one is the angle T. From the very basic right triangle, if this is the angle theta or the hypotenuse y x, we see that sine of the angle theta is y over r, meaning that y is r sine theta. Cosine of the angle theta is x over r, so x is r cosine theta. Look at the right triangle inside that has the hypotenuse 1. Adjacent side is cosine p. Opposite is sine t. Now we're going to take a look at the right triangle that is below. We see that adjacent is going to be the radius of the hypotenuse r multiplied to cosine s. So that is the cosine t cosine s. The opposite is cosine t sine s. Okay. And this angle right here is 90 degree minus s. Well, because that is 90 degree minus s, so this angle is s, which means that we're gonna use the same concept to figure out all the side of this right triangle. The hypotenuse side t, right? Adjacent is going to be a side t cosine of s. Opposite is sine t sine s. Okay, one more right triangle. This is the last one. So we know that this angle here is T plus S. So I mean, this angle is 90 degree minus T plus S. Okay. And so this angle right here is T plus S. Okay. We're going to focus on the angle T plus S. Adjacent is cosine T plus S because the R is equal 1. Opposite is sine T plus S. We got everything here. Let's do a comparison and you see. So as you can see, sine T plus S is equal to sine T cosine S plus cosine T sine S. Yay, that is the first identity. Right? And then if we look at the cosine of T plus S, right? So that is the cosine T cosine S minus sine T sine S. Wow, amazing, huh? We just proved the sum identities. There are more. Double angle identities. Sine 2x equal to sine x cosine x. And cosine 2x is cosine square x minus sine square x. And because cosine square is 1 minus 2 sine square, we can rewrite it as 1 minus 2 sine square x. And notice that sine square is 1 minus cosine square. So that gives us 2 cosine square minus 1. Tangent 2x is 2 tangent x over 1 minus tangent square x. So here come a proof. One of them on the side 2x equal to sine x cosine x. Sine 2x, I'm going to work on the left side. It's sine x plus x. Right? And then we use the sum identity. Well, sum identity tells us that this is the sine x cosine x plus cosine x sine x, and that gives us exactly 2 sine x cosine x. Pretty cool. Half angle identities. Sine of, let's say the angle u over 2 is plus or minus root of 1 minus cosine u over 2. Cosine u over 2 is plus minus root of 1 plus cosine u over 2, and tangent u over 2 is either 1 minus cosine u over sine u or sine u over 1 plus cosine u. We just have to multiply by the conjugate, and that is what we get. Here come one of the proof. We're going to show that sine u over 2 is equal to plus or minus root of 1 minus cosine u over 2. Well, one of the best way to do this one is that we're going to borrow the power reducing identity. and work out the sine square u from there. From power reducing identity. Oh, we should have proved that one first. Sine square u is 1 minus cosine 2u over 2. And here we can divide the angle by 2. Get a sine square u of 2 is 1 minus cosine u over 2. Okay. Next step is we're gonna square root both sides. And that gives us sine u over 2 is plus or minus root of 1 minus cosine u over 2. Power reducing identities. Sine square x is 1 minus cosine 2x over 2. Cosine square x is 1 plus cosine 2x over 2. And tangent square x is 1 minus cosine 2x over 1 plus cosine 2x. Let's prove one of them. Well, since we use the power reducing identity in the proof of half angle identity for the sine square, so let's prove that sine square x is exactly 1 minus cosine 2x over 2. Well, best way to deal with this one is work the right side out, because we can simplify that one. So this half 1 minus cosine 2x, right? We use the double angle identity. That gives us the cosine square minus sine square. And then from there, we have half of 1 minus cosine square plus sine square. Oh, 1 minus cosine square. Ta-da! Pythagorean identity. Half of sine square plus sine square. And we have half of 2 sine square, which is sine square. That's it. We just proved the identity. Pretty amazing. Right? It will be more amazing if we can apply this identity. Let's take a look at some application. 2. Exact value. Example. Find the exact value of cosine 105 degree. There are 2 ways that we can do it, because the 105 degree is the same as 60 plus 45. Yeah. Cosine 105 degree is the same as cosine of 60 plus 45 degree. And then we know how to take sine cosine of 45 60 degree. Well, that is the sum identity. So it will be cosine of 60 degree, cosine of 45 degree minus sine of 60 degree, sine of 45 degree. Half times root 2 of 2 minus root 3 over 2 times root 2 of 2. And that gives us 1/4 root 2 minus root 6 Wow. What is the second way to do it? 105 is 210 divided by 2. Cosine of 105 degree is cosine of 210 divided by 2. Oh, we can use the half angle identity. This would be negative. The reason why is because 105 degree is in quadrant 2. So cosine of an angle in quadrant 2 is negative. Root of 1 plus cosine of 210 degree over 2. And this gives us negative root of 1 plus, okay, so cosine of 210 is negative root 3 over 2. Over 2. Well, we can simplify this to be negative root of 2 minus root 3 over 4. And it is the same as negative 1/2 root 2 minus root 3. The two answers, they don't look the same. However, if we convert them to a decimal, this one is negative 0.2588, and this one is exactly the same, negative 0.2588. Oh, very cool. Second example, verify the identity cosine to the 4x minus sine to the 4x equal cosine 2x. Oh, pretty cool identity. Well, look like we can simplify cosine to the 4 minus sine to the 4 by factoring. So work it out and show that it is exactly cosine 2x after all the simplifying. So we can factor this out. Cosine square x minus sine square x, cosine square x plus sine square x. Oh my god, cosine square minus sine square is cosine 2x. Cosine square plus sine square is 1. So that is it. It's cosine 2x. Oh, very quick. I like it. One more example. Given sine of the angle theta is negative 2 over 5 in quadrant 3. That is the number 3 here. Roman numeral, 3 is better. Find cosine theta, sine theta of 2 and sine of 2 theta. Okay. First thing is, let's sketch out the angle theta is in the third quadrant. It is the corresponding right triangle. Opposite is negative 2, hypotenuse 5. So adjacent is, I'm going to call it x here. X squared plus minus 2 squared equal 5 squared. So x squared plus 4 equal 25. X equal 21. No. X squared equal 21. So x equal 2 minus root of 21. The reason why, because the x is on the left side of the origin, so it is negative. Once we get x, then we can figure out the cosine of the angle theta is adjacent over hypotenuse, so negative root of 21 over 5. Sine of theta over 2. Well, that would be a positive root of 1 minus cosine theta over 2. The angle is positive because we know theta is in the third quadrant, so that is between 180 degree and 270 degree, which tells us that theta over 2 is between 180 divided by 2 is 90 degree, 270 divided by 2 is 135 degree. Yeah. Theta over 2 is in Q2, second quadrant. Yeah. And in second quadrant, sine of the angle is positive. Now just do the substitution in here. Square root of 1 minus the cosine is negative root of 21 over 5, and then divide by 2. Simplify this, and we have root of 5 plus root of 21 over 10. Yeah, whatever that is. Right. Sine of 2 theta is, well, from the double angle identity. 2 sine theta cosine theta, which is 2 times sine of the angle theta is negative 2 over 5, cosine of the angle theta is negative root of 21 over 5. So that gives us 4 root of 21 over 25. Thank you for watching. I hope you found the content useful. Please like, subscribe to help the channel grow. I will see you in the next video.